Hi guys, welcome right now to paper 2. Okay, we'll just go through very quickly the whole paper. First question is on two tugboats having two forces 60,000 and 90,000. So obviously the longer one is 90,000, shorter one 60,000. Most common mistake that's used here is that instead of getting a proper scale, some of you just use this entire length. You can see this length is not a fixed number. It's not a whole number. It's actually 5 point something. So you cannot make like 5.6 cm to represent 90,000 newtons, right? Okay, so you need to be something that is rounded off. So 1 cm, the closest will be probably to represent 15,000 newtons. So if 1 cm represents 15,000 newtons, 90,000 newtons will be 90,000 divided by 15. That will give you 6 centimeters. So instead of 5, okay, we'll just draw it out to 6. So this one is 6. And the other one will be 60,000. 60,000 will be 4 centimeters. So 4 centimeters here. Okay, 4 centimeters. So you got to extend it out. Okay, so right now, if this is 60 degrees, how many will this be? So this will be exactly 120 degrees. So that's how you draw a parallel line. So if I were to put it here, okay, 120, and roughly in this direction, and this one also will be 120. Okay, so if I want to extend it, there's a dotted. This one also extend it, dotted lines. So boom, we can see an intersection here. So this will be the other end. So from here to here. Okay, so you can get your rough parallelogram shape. That gives you 1 mark. Another mark for drawing the correct arrows, not just this two component, but also your resultant arrow here. Okay, and third mark will be basically your final answer, which is if I were to measure it out, okay, it will be exactly 8.5 cm. So 8.5 cm, or roughly you have to convert it back. So 8.5 cm. So that's about 15,000. So basically the answer will be around anywhere between 124,500 newtons to 137,500 newtons. So anyone within this range, we will accept. Anything bigger outside of this range is because your drawing is not accurate enough, or you use the wrong scale. Okay, got it? So basically just a straight line with arrows, double arrows for your resultant, and dotted arrows for the non-component forces. Okay, so whatever your answer here, they ask you now, next part, calculate what is the acceleration. So F equals ma using a. If I were to use the answer of 230,766 divided by 50,000 is given, 50,000, so the answer is about 2.62 meters per second square. Okay, so explain, how does the acceleration compare with the value? So of course the acceleration actual smaller. Okay, why? Okay, because there will be additional forces. Like what? Additional forces like friction and air resistance will do what? Well, what sort of effect does it have? Will reduce resultant force. Okay, causing it to have a lower acceleration. Okay? Alright. So let's go to the next question. Next question over here. This was quite well answered. Okay. Basically, if they tell you it's 0.9 seconds all the way from A to C back to B, so the answer would just be 0.9 divided by 3 times 4, because 1, 2, 3 times 4, 1, 2, 3, 4, right? So answer 1.2 seconds. That's it. Okay, so describe and explain. So you see there are two parts, huh? Describe and explain. Okay, so first part here will be to describe. You can just say measure 10 oscillations and take the average. And the second part will be basically why do we take average? Okay, because by taking average, this reduces what does it reduce? If you put human error, you don't get any mark, because there are many types of human errors. Okay, so it's human reaction time, okay, error, where at start and end times. Okay, so basically if you measure 10 oscillations, take average, you actually reduce. You only have one error, which is at the start of the first oscillation, and the last one at the 10th oscillation when you press stop, right? So you actually divide it across 10 oscillations. Okay, okay, this question 3 is basically just plotting. So if we were to plot first part here, time equals to 0, moves off from rest, so this one is 0, 0. Okay, after that, travels at uniform rate to a speed of 25 at 10 seconds, so 10 seconds, 25, so it's here. Okay, travel constant speed another 15 seconds, so 10, 15, so somewhere here. Okay, it then brakes are applied and it comes to rest in the further 25 seconds, so 5, 10, 20, 25, all the way here. Okay, so if I want to draw, just to combine the straight lines together. Okay, and that's it. Okay, 2 marks for this question, 1 mark for plots, 1 mark for the correct shape. Okay, alright, so calculate total distance traveled. So total distance, first thing, speed time graph, right? So speed time graph, two things again. Acceleration gives me or rather gradient gives me acceleration, and area gives me distance, right? So I'm using this relationship. So distance equals to area of the graph, which is equals to, and treat this as a trapezium, right? Okay, half sum of sides, which is 50 plus 15 times perpendicular distance 25. Okay, answer is 812.5 meters. Okay, average speed. Average speed is simply average speed is equals to total distance divided by total time. Total distance, you got it here, 812.5 divided by total time taken. You can see it's actually 50 seconds. So answer 16.25 meters per second. That's it. Okay, so for question 3, question 4. Question 4 is pretty straightforward. Describe runner's motion from 0 to 3. So 0 to 3, what can you say? Okay, the speed, this one increased by 0.5 over here. Increased by 1, this one. Increased by 1.5. Oh, can you see this tree? What is increasing? Not just the difference in the speed, right? So it's not just the speed is increasing, but the rate at which the speed is increasing. In other words, what kind of speed is it? It's increasing speed at an increasing rate. Or you can say increasing acceleration. That's right. Okay. And finally, for this question, runner's acceleration at 6, from 3 to 6. Okay, so this part here. Okay, so if I want to find acceleration, will be A equals V minus U over T. So V is 12 minus 3 divided by T, which is 6 minus 3. 9 divided by 3, which goes to 3 meters per second square. That's it. Okay, this was done quite well. Okay, Looking at this, okay, total volume of HSLA. So basically, we have a couple of materials here. Most common mistake is that you add densities. You can't add densities. You can add masses, you can add volumes, but you don't add densities, okay? So in this case, how do we calculate volume? Okay, you're gonna use this relationship, mass density equals to mass over volume, right? So volume, mass over density. So mass over density plus mass over density plus mass over density, right? So total volume, which is equals to basically 5,909,000 divided by 7870, okay, plus this one 175,000 divided by 3,500 plus 355,000 divided by 7,100. So you can see I'm adding 3 volumes of the 3 different elements: iron, carbon, and manganese. Okay, so total answer I'll get 800 cubic meters. Okay, 1 mark for 2 of them, any 2 terms you get correct, and the third mark for the second mark for all 3 terms, and the third mark for the final answer. So calculate density, same thing, density, mass over volume. So total, now I can use total mass over total volume, right? Total mass over total volume. Total mass is given, what is total mass is actually given as, or just add all these 3, right? So 5,509,000 plus all the way to 355,000 divide by whatever answer I got here. Okay, so this answer, the density will be 7550 kilogram per meter cube. Got it? Straightforward. Okay, so given the water density is this, HSLA will sink in water. Explain why. Okay, so common mistake here is that some of you just say the density of HSLA is less dense, or the density of air is less dense. Yes, you're right, but actually you're not really correct, because the density of HSLA is bigger. Okay, but even you were to say the density of air is lower, but so what? Okay, so the main thing is that the average density of both HSLA and air is lower than water, so it floats. Okay, all right, so that's it for part B. Part C will be this one, 60,000 pascals. So explain what it means. So many of you just state 60,000 pascal, it means 60,000 pascals of pressure. It can withstand this amount. Don't need rephrase using English. Okay, you have to use a scientific principle. Okay, and so one of the keys over here will be, what does pascal mean? Okay, it means 60,000 newtons of force per square meter. Okay, so main door, Mary, this was done pretty well. Okay, just pressure equals to force over area, so force pressure times area, which is equals to 60,000 times 220,000 newtons. Okay, full marks for this. Okay, second last question in this part. So explain why the competitor lifts the log at the end instead of any other position. Okay, you gotta know this is a moment question, right? So moment is equals to force times distance, right? Okay, so there are 2 concepts here: force, distance. So why does it go to the end? It goes to the end. If I pivot at A, what's happening? It has maximum distance. So maximum distance will result in a maximum produce a maximum moment. Okay, so basically the idea here is just you have to say the variables. Okay, so maximum perpendicular distance, which is from pivot, okay, results in what? So by having a maximum perpendicular distance results in maximum moment to lift the lock. Okay, how do you lift the lock? Not the whole lock come out like that, right? Because maximum distance, maximum moment, so you can actually rotate the lock. So in a way, it's actually lifting it. Okay. So this one, some clockwise moment equals some anti-clockwise moment, right? So over here, they tell you it is a uniform lock, pivoted at A. Okay, so how long is the lock? 6 meters. So center of gravity here will be 200 newtons. So this 3 meters. What force is this? This force is what I don't know, which is what they want to find out. So F, so this total distance is 6 meters. So you gotta pivot here. So clockwise moment, which one gives me clockwise? The force, right? So F times 6 equals to anti-clockwise 200 times 3, right? So F is simply equals to 100 newtons. Okay? Got it? Okay, going to the next question. Okay, when fired, the dart compartment exerts force of 10 newtons over distance. So I got force and distance, so work done. This was done pretty well. Force times distance, 10 times 0.3 equals to 30 joules. Okay. Oh, sorry, 3 joules. So 100 darts per minute, so power equals to work done over time. Work done is 3 joules, but I got 100 darts, so I times 100 divided by time per minute, 1 minute, but I got a time 60, right? So answer is actually 30 divided by 6, 5 watts. Okay.